So in this video, we're going to explore how we find the derivative of f of x equals x squared, a basic quadratic. So instead of jumping right into the definition or the proof, we are going to examine this more conceptually using the graph of the function. So here we have the graph of x squared. Our goal is to find the derivative of this function, but for now we're going to focus on just one point. So our motivating question for this part of the lesson is, what is the derivative at x equals 1? And remember, the derivative is the instantaneous rate of change or the slope at that point. So to do this, we're going to look at a series of secant lines. The first secant line we're going to look at is at x equals 3. So we're looking at the line between 1, 1, and 3, 9. So with these secant lines, we're going to start with one that's at 3, and then we'll slowly approach x equals 1. So we'll slowly approach the tangent line. First, let's just find the slope of this secant line. So we take the difference in the y divided by the difference in the x. So that's 9 minus 1 divided by 3 minus 1, 8 divided by 2, which is 4. So using the secant line, our best guess of the slope at x equals 1 is 4, because the slope of the secant line is 4. But we want to make this approximation better, so let's find another secant line. This time we're going to use x equals 2, so our secant line goes between 1, 1 and 2, 4. To find the slope of this line, we do the difference in y divided by the difference in x. So it's 4 minus 1 over 2 minus 1, which is 3 over 1, which is 3. So the slope of the second secant line is 3, and we're getting closer to the true value of the slope at x equals 1. We're going to repeat this process 2 more times, so let's bring our secant line even closer. For our next secant line, we're going to use the point 1.5, so we're at x equals 1.5. Really quick, let's compute the y value that goes with this x value. To find this using the equation, we can use x squared, so 1.5 squared, which is 2.25. So that matches our point on the graph. X is 1.5, y is 2.25. Then we can find the slope. So we have 2.25 minus 1 divided by 1.5 minus 1. Then after some calculations, we can find that that is 2.5. So the slope of this secant line is 2.5. We're going to do one last secant line. Remember, our goal is to find the slope at x equals 1, so we're getting these secant lines even closer to 1. This time, let's do x is 1.25, so plugging that into the function, we get 1.25 squared, which is 1.5625. You can see that the graph rounds this to 1.563. Then we can find the slope between those 2 points. So I'm doing the change in y divided by the change in x, doing some calculations, and I'm getting that the slope is 2.25 for this secant line. So we've been using the secant lines to try and approximate what the tangent line is at x equals 1. We're trying to find the slope of the tangent line. So by bringing the secant lines closer and closer together, we can look at how their slopes have changed. So we went from a slope of 4 to a slope of 3 to a slope of 2.5 and then 2.25. We could continue this process, bringing the secant lines to be closer and closer to the tangent lines by making the distance between the points smaller. But we can see here that maybe the slopes are approaching 2. That's my best guess so far. We got to a slope of 2.5, then it went down to 2.25, and so maybe the next slope would be even closer to 2. So that's my best guess, but in the next video we are going to do this more formally using the limit definition, and then we will know the derivative of x squared so that we can find the slope at the value x equals 1. Please go watch that next video. It made more sense to put these into 2 separate videos on the technical side, so if you could go watch that one now, that would be great. We get to finish off this argument and discuss how we actually find the derivative of x squared. Thank you, and I'll talk to you in the next one.